In this video, I'm going to show you how I added blocks to the game that aren't supposed to be there. Hey guys, Swifter here, and welcome to Module 1 of Survival Plus. The theme for this module is machines. I have split this video into two parts, part 1 being a showcase and the other part being a technical breakdown. To learn more about Survival Plus, you can click the top right corner. The installation process is also included in that video, so make sure to check it out. Without further ado, let's get into this episode. Let's start off with the first machine, the Redstone Clock. To craft the Redstone Clock, you will need 1 clock, 4 redstone dust, and 4 stone blocks. When placed down, you will be prompted with an overlay showing two values. The first displays the amount of time it will take for the clock to pulse. The second displays the amount of time the clock will pulse for. You can adjust the values by scrolling across your hotbar with your scroll wheel. By default, you are targeting the first value, but if you hold down crouch, you can target the second value. You don't have to click anything extra to update the timing, because it is applied in real time. The redstone clock will also turn off if you power it with a redstone signal. That's all for this block. Now on to the block breaker. The block breaker is crafted using 1 iron pickaxe, 1 redstone dust, and 7 cobblestone. The block breaker can be placed in any direction depending on where you are facing. When the block breaker is powered, as you might have guessed, it does absolutely nothing. Assuming you haven't added some kind of item for it to actually break the blocks with. The machine will only accept 1 item to use, so if you try to put more than 1, it will just spit everything out. Now when the block breaker is powered, the block in front of it is broken, with all the effects of the tool inside applied to the block. Let me give you an example. If you add an iron pickaxe to the tool slot, it will take damage. Now you might be thinking, that's pretty useless. But I'm talking about all of the effects of the tool inside. So if that iron pickaxe happened to have silk touch on it, the block in front of it would also have that effect applied. The same goes for fortune and unbreaking. The block breaker also has a counterpart, the block placer. The block placer is crafted using 7 cobblestone, 1 redstone dust, and 1 piston. Again, the block placer can be placed in any direction. When the block placer is powered, it will do the opposite of the block breaker and places the blocks inside of it. It will choose a random block, just like a regular dropper or dispenser. If there's already a block in the way of the block placer, it will just destroy that block to replace it with a new one. If the item it chooses is not a block, it will just be spit out of the block placer. The block placer can also place other custom blocks, such as the item filter. The item filter is crafted with 5 iron ingots, 1 observer, and 1 dropper. The item filter acts mostly like a hopper, but with a few differences. For instance, there's a custom GUI with 3 slots. These are used to choose the filter items. The item filter is pretty complicated, so I'll explain the rules to you. Firstly, the item filter will only suck in items if they match the filter items. Secondly, the item filter will spit accepted items out to the direction it's facing, and won't go directly into an inventory except for hoppers. Items can be sucked in off the ground or by another inventory above it. It even works with double chests, which was a lot of extra effort to code. If the items do not match, it will just leave the item in the container. However, if the item is forced in, whether that's manually or with a hopper, it will reject the item. Unfortunately, due to the way hoppers work, if you place a hopper under the item filter, it will suck out the filter items. There's nothing I can do about that. Item filters can also be locked if you power it with redstone, which means it won't suck any items in. Keep in mind this doesn't include stopping items from being forced in. Alright, now onto the final block in this creation, the counter. The counter is crafted using 3 lapis lazuli, 4 stone, 1 redstone dust, and 1 redstone repeater. The counter is yet another fully orientable block. When placed down, the counter has an overlay similar to the redstone clocks. There's 2 values you can adjust, with the same scrolling and crouching controls. The first value represents what progress the counter is currently at, and the second value represents what the counter is counting to. The first value can never surpass the second value, and if you try to adjust the progress past it, it will just send it back to 0 and vice versa. When the counter is powered at the redstone signal on the detecting side, it will count up by 1. When the counter reaches 100%, it will send out a redstone signal at the output end of it. If you activate it again, it will reset back to 1. So, now that I've shown you what goes on the outside of the blocks, I'm going to show you how it looks on the inside. Okay, let's start at the very beginning. How do you create a new block in Minecraft? No mods, and no replacing old blocks. Well, technically speaking, that's impossible. You cannot add a new block to the game. As in, you cannot create a unique block ID with unique properties. However, with enough patience, you can essentially recreate what makes a block a block. So first, we need to add a new model to the game. Previously, you would have to either replace existing items or remodel tools based on their damage state. However, with the new addition of the custom model data tag, you can make any item use any custom model of your choice. But that doesn't fix the issue that when you place down the block, it will still just remain as its regular state. So, what now? If you can only have the custom item in your hand, what can you do? Well, the answer is armor stands. If you put an item with a custom model on an armor stand's head, you can use its head display options in its model to scale and translate the model to cover the top of a block of your choice. Okay, so let's see what happens in game. That's right, ever notice that entities inside of blocks become dark? That's kind of a big problem. But we can just set the armor stand on fire and the fire animation won't display because the armor stand has the marker tag. Well, now we have a whole different problem. You see, the way marker armor stands work is that if their feet get off screen, they will stop rendering. So if we center their feet right in the middle of the block, it works out just fine. So, we have a mock-up design of a working block we can use. Now how do we get an item that the player can use to place this block? Well, that's a whole other issue, but there is a solution, and that is bat spawn eggs. With spawn eggs, we can actually change what entity it spawns. We can also use custom model data to change the model of the spawn egg. But unfortunately for us, that is NBT data which needs to be specified somehow. So how on earth did we get the block accessible in the creative inventory? Well, here's the kind of disappointing part of the data pack. We don't have to replace any blocks in survival for this to work, but we do need to replace the model and name of 5 spawn eggs. It's not a huge deal because the only functionality is to spawn mobs, which can be done with /summon, but still a little bit of a disappointment. Technically, this system is infinite, but you wouldn't be able to craft any blocks or take them from the creative inventory until that is implemented to the game. So anyways, we have for example a blaze spawn egg that we need to convert into our custom bat spawn egg. So how do we give the player the updated spawn egg? I mean, we could just clear the player's inventory of blaze spawn eggs and give them a bat spawn egg in return, but we would lose the slot and count information, so you would lose blocks in the process. And we can't edit the NBT of the blaze spawn egg directly because /data doesn't work on players unless you're grabbing information. So, the solution is jukeboxes. Don't worry, the workarounds only get weirder from here. Jukeboxes have a very special property that allow you to store arbitrary NBT in them. Arbitrary NBT is basically just a place we can store any type of NBT without the game correcting it, like removing the slot tag. The arbitrary NBT is stored in the stored items tag of the jukebox's record item, which in this case is a stone block. We can store the player's inventory in the stone block and change any blaze spawn eggs to our special bat spawn egg, and it will keep the slot and count information. So the next step is to get it back into the player's inventory, and for that we are going to need a yellow shulker box. To be more specific, I have a loot table, which means if I mine the shulker box with air that has the tag drop contents 1B, it will drop all of its contents on the ground. I can use this with loot replace to essentially drop all of the shulker box's content, which happen to be a modified version of the player's inventory, directly into their inventory again. This works perfectly, but there is still a bit of an issue, which maybe you can figure out if you look at a shulker box's and a player's inventory side by side. Notice anything? Well, if you didn't catch it, the player's inventory is exactly 9 slots larger than a shulker box's. It actually only copies these slots into the shulker box because slot 0 starts at the player's hotbar. So now we have to repeat that whole process again for the remaining 9 slots. Hooray! Now it's working, and we have a functioning way to get custom blocks. Now onto the block's mechanics itself. I'm going to talk about these blocks in the order I made them, so let's start with the redstone clock. For the redstone clock, I needed a block that can detect a redstone signal and another block that can create a redstone signal. So the block I chose was alternating between a redstone lamp and a redstone block. The main issue with these blocks, though, is that the redstone lamp's particles can be seen and the glass sound is made when it's broken. If I'm going to remove particles from the redstone clock's redstone lamp, I need to remove it for every redstone lamp. So I changed the model to have no particle effects, and I needed to figure out a way to add the particles back to the regular redstone lamp. At the same time, I realized that if I was going to make the redstone clock not sound like it was made out of glass, I had to remove the glass sound from the game entirely. This is unfortunately just the way the game works. The sounds that blocks make are hard-coded into the game, and the only way to remove them is to make them all silent. However, there is a workaround which involves manually adding in fake particles and fake sounds. So I edited the loot table of all the glass-related blocks to an invisible spectral arrow which will play my custom sound. And if it happens to be a redstone lamp, it will run a function that runs 64 individual block particle commands. In order to use the correct particle, I needed to use another block's particles and retexture it to a redstone lamp, so I used data structure blocks. This works well enough, except for the fact that creative mode players won't spawn the items when they destroy things because loot tables don't activate in creative mode. So I set up a basic raycasting system that will stop if it detects full blocks or if it finds a glass-related block and do its thing. From there, I can temporarily disable tile drops, then destroy a smooth stone block to create a stone sound and stone particles for the redstone clock. I don't have to worry about the redstone block because it makes a stone sound anyways, and the red particles match my texture well enough. In order to create the custom overlay for the redstone clock, I used the game's subtitle feature combined with some slick custom characters. I use the same custom character system as I did for the temperature system, so go check that out if you haven't already. The custom characters are positioned in such a way that the size of the numbers actually dynamically adjusts the size of the overlay. The clock's math was actually pretty easy to do. Just count up until you hit the set limit and go back to 0 and switch to the next limit. The actual scrolling part was pretty challenging though. If you are going too fast, it's not really able to keep up due to some basic logic. Let's imagine a scenario where your selection goes from slot 4 to slot 5. That can be interpreted as either moving one slot to the right, or 8 slots to the left. So I found it working good somewhere around 5 slots per tick. Any faster than that and the game will get confused. The actual math was calculated by comparing the previous tick slot position by the current tick slot position. If I get something like, for example, -8, that would probably mean the player was on slot 8 and then scrolled forward to slot 0. When breaking a redstone clock, I just convert any nearby redstone block or redstone lamp items with age 0 and convert them to the bat spawn egg. Now let's see how block breakers work. It might have been obvious already, but I'm using a dropper for this block. It works perfectly for the mechanics I need for the block breaker. The only downside of a dropper is that if there's a container in front of it, instead of dropping an item, it will just transfer that item into the container. In order to place the model in a specific orientation, I have to make 6 models and detect where the player is facing. The custom GUI is actually more custom characters scaled in the right way to cover the slots. I actually have to rename the block to get custom characters, so I have to use a random Unicode character. Droppers don't actually drop items as soon as they are powered, so I have to buffer the powering with a scoreboard. If any item with an age of 0 spawns close to the sides of a block breaker within 8 ticks of it being powered, it will count that item as the item it's using to break the block. The part about using enchantments on the block works by cloning the item's NBT to an armor stand and using the armor stand to loot the block it's inside of with a weapon in its hand. Making the tool take damage works by storing the tool's damage tag in a fake scoreboard, removing that score by 1, and applying it back to the damage tag. For every level of unbreaking, I spawn a new temporary area effect cloud. I target a random one including the item, and if it happens to be the item, I take durability away. Now onto the block placer. This block was probably the least effort to make out of all the blocks, because it's pretty similar to the block breaker. I pretty much use the same orientation system and powering detection system as before. But there was still one big roadblock, which was to actually get items into block form. The idea is to use a falling block and apply the item's ID to the block state of the falling block. The only issue is that if something is not a block, for example a diamond sword, it would obviously not work, so I had to spend an afternoon hard-coding every single non-block item in the game. Or so I thought. Turns out if you try to apply a diamond sword to a falling block, it just doesn't do anything. The only issue is I figured this out after I had hard-coded all of the items in, which was a bit disappointing, but hey, now it's a little bit more future-proof. Of course, I still had to hard-code some exceptions, like for example, doors. It works pretty much seamlessly now, but there is the problem that if there's no block under the falling block, it will just keep falling, so keep that in mind. The item filter was by far the hardest block to code, as you would imagine. First of all, I didn't actually use a spawn egg for this one. This is because I needed to figure out which face of the block the item filter was placed on, so I decided to go with item frames. The thing about item frames is, you can't make them invisible, so placing them would give you this flickering effect which really ruined the immersion. So I removed all of the item frame models from the game and made some fake ones. For the item frames that aren't used in my system, I figure out their orientation and summon the corresponding armor stand with a model on its head to create the illusion of the item frame. It still functions the same, but it has an armor stand there. So for the block that I chose, I think it was pretty obvious to go with hoppers. They are pretty small containers, and they transfer items. It's perfect. Well, almost. To start off, hoppers are very annoying in this game. The only thing you can do with them is lock them, and that barely does anything. Locking a hopper only means it can't transfer items, but it will still accept items. So I had to figure out a way to make this behavior work with my idea. First of all, this means that we would have to lock the hopper and manually deposit items of our choice. Manually depositing the items, of course, means that we have to compare them to the filter items, and depending on whether they match or not, spawn them in the top or on the side of the hopper. Comparing the items is pretty complicated, and includes some more jukebox arbitrary NBT stuff. There's so many things that have to go over that it's not even worth mentioning, so if you're really curious, you can go download the pack and check for yourself. Otherwise, you're just gonna have to take my word for it. So great, now items that are forced into the hopper are pushed out in the correct directions. But what about accepting items? Well, for that, we have to essentially recreate the mechanics of hoppers. So here's the issues we run into. Let's say we have a chest as our container with these items in it and a stone block as our filter item. How do we find the stone block in the chest? Well, you have to go through all of the contents of the chest one by one until one of them matches. Even then, what do you do though? How do you take that item away from the chest? How about only taking one item away from it at a time? This is where I started getting very worried about this project. But luckily, some very smart people at r/Minecraft commands were able to help me out here. So, what we can do is take the chest's contents and put them into a jukebox. Then we can go through the chest's contents one by one and see if they match. If they do, we take the item's count, subtract it by 1, and put it back. We then copy all of that info back into the chest and keep the NBT of the item that matched, and from there we can spawn that item next to the hopper. Of course, this is very summarized and it took way longer to figure out all the details, but that's not too important for the general concept. Okay, so now that we have that part working, we need to make it work with double chests. This part was very hard still, but luckily chests were coded very nicely for us map makers, because the chest stores its type and direction inside of it. This is important, because the direction combined with the side of the double chest tells us exactly what the rest of the chest looks like. We also need to take into consideration that we want the system to take items top to bottom, and each chest corresponds to half of the inventory. The chest that counts as the top or the bottom changes depending on the direction, so we have to account for that too. So, after we figure out where the second chest is, we can apply the container sorting system from earlier to both of the inventories. Again, all of this math stuff is very generalized, and if you want all the details you can look at the pack, because this video is already long enough. And last but not least, we're going to take a look at the counter. The counter was still pretty complicated to figure out, but luckily it was mostly math, which I don't have to explain in too much depth. So, the block I chose for the counter was an observer, because it creates a redstone signal in one direction, it makes the stone sound in stone particles when it's broken, and it's orientable. So, I used pretty much the same overlay system as the redstone clock, but with new visuals. And I used the same orientation system as the previous orientable blocks. But we're not getting off the hook that easily. The thing about observers is it's kind of impossible to prevent them from activating. Even if I spam the observer with an off state, it would always make a little 0-tick redstone pulse. So I had to add a new type of block to the creation. I decided to use glass for when the counter was off and keep the observer for when it's on. Glass is good because now I can control the sounds and particles it makes, it's a full block, and it's transparent, which means redstone won't travel through it. With a bit more tedious adjustments, I was able to make the glass work pretty seamlessly. So, now we needed to detect redstone signals, and for that I had to hardcode every redstone source in the entire game, and detect its orientation and everything. It was a bit of a grind, but now it detects every redstone source in the game as if it was a vanilla block. Now I just needed to do the math for the block and make the block light up when it's activated. I actually used a trick I'm pretty proud of for the activated skin. Since there were 6 models for the off and on state, that means that any of these models would have the opposite state exactly 6 lines from it. So whenever I wanted to change to a new state, I took the current custom model data, changed it by 6, and set it back. And that worked actually perfectly. If I didn't do that, I would have to hardcode every single direction twice. Pretty cool workaround. This data pack was really a learning process for me. Even after 4 years of coding in this game, I still have a lot to learn. There were multiple times through this project where I wanted to quit, because I thought it was impossible. But I kept going, and I found out ways to get around those issues. I feel a lot more confident in my skills, and I hope you enjoy my creation as much as I did making it. As you could imagine, this video and the creation took me ages to put together, so it would be highly appreciated if you considered subscribing. See you in the next one.